Hello again fellow technology fans, and welcome back to the channel. In this video, we will be providing an overview of the major developments in computing, from the 1940s up to the present day. The computer revolution, that has taken place over the last 70 years, has profoundly changed human society. Computers now underpin almost all aspects of modern life, from communication, entertainment, transportation and more. But this was not always the case. The origins of computers are humble, and their rise to ubiquity and indispensability has been driven by key innovations in technology. The first concept of a computing device was the analytical engine, proposed by mathematician Charles Babbage in 1837. While the analytical engine was never built, it contained many features of a modern computer such as an arithmetic logic unit, control flow, memory, and integrated operations. Computers would not become a practical reality until the 1940s. During World War II, fledgling computing concepts played a crucial role in the war effort at Bletchley Park in Britain. A team led by Alan Turing designed electromechanical machines to decrypt messages encoded by the German Enigma cipher machine. This allowed the Allies to intercept critical Nazi communications throughout the war. While primitive compared to modern computers, the Bletchley Park codebreaking effort demonstrated the potential of computing for cryptography and national security. The first electronic general-purpose computer was the Electronic Numerical Integrator and Computer, or ENIAC, built at the University of Pennsylvania in 1946. ENIAC filled an entire room, contained over 17,000 vacuum tubes, and could perform approximately 5,000 calculations per second. It was programmed manually by rewiring plug boards and setting switches, a laborious process. Nonetheless, ENIAC represented a major breakthrough and demonstrated the potential for electronic computing. In 1948, engineers at the University of Manchester built the Small-Scale Experimental Machine, or SSEM, the first stored program computer. The SSEM stored instructions in memory, executing them sequentially, which allowed for greater flexibility compared to the ENIAC manual programming. This concept, known as the von Neumann architecture, became the standard model for computer design. Vacuum tubes were later replaced by transistors, enabling computers to become smaller, faster, cheaper, and more reliable. Throughout the 1950s and 60s, computers remained massive machines run by corporations and governments, dedicated to scientific and military applications. The machines relied on punch cards and printouts, and interaction was limited to programmers and technicians. In 1964, IBM introduced the IBM System 360, the first family of computers intended for both commercial and scientific uses. The System 360 used interchangeable software and peripherals across its product line, which greatly increased the flexibility and speed of development. In 1969, the Unix operating system was developed at Bell Labs. Unix became widespread in universities and companies due to its portability across different platforms. This modular approach made it a forerunner to the open-source movement that would emerge later, with Linux and other software. The microprocessor was another crucial breakthrough. These miniaturized central processing units enabled computers to become much smaller and more affordable. The first single-chip microprocessor was the Intel 4004, introduced in 1971. Microprocessor technology advanced rapidly through the 70s, with the 8-bit Intel 8080 in 1974, powering early personal computers like the Altair 8800. The stage was now set for the dawn of personal computing. In 1977, Apple Computers unveiled the Apple II, one of the first mass-produced home computers. The Apple II was a major success, demonstrating the commercial viability of personal computers. Other important home computers of the late 70s included the Commodore PET and the Tandy TRS-80, sold through Tandy's Radio Shack stores. A major spark for home computing was the introduction of the spreadsheet program VisiCalc in 1979, running on the Apple II. VisiCalc showed business users how useful and convenient the technology could be for accounting, forecasting, and more. Productivity software for word processing and databases soon followed. The IBM PC arrived in 1981 and soon dominated business computing, while Apple found success in education. Home and office computing continued growing through the 1980s. The graphical user interface, or GUI, was another significant milestone in making computers accessible to everyday users. Instead of typing commands, users could now manipulate visual icons and windows with a pointing device like a mouse. Apple's Macintosh in 1984 was the first mass-market computer with a GUI, following on research done at Xerox PARC. Microsoft Windows, however, soon became the dominant GUI-based operating system. The development of computer networking was also pivotal. Local area networks enabled groups of computers to communicate, while the Internet allowed global connections. Tim Berners-Lee invented the World Wide Web in 1989, kickstarting the Internet era. As Internet usage grew through the 1990s, computers became portals to a world of information and communication. Other major computing milestones in the 90s included IBM's Deep Blue supercomputer, beating world chess champion Garry Kasparov in 1997, demonstrating the increasing power of computers for complex tasks like game playing. Handheld computing also emerged with personal digital assistants like the Palm Pilot, and eventually smartphones like BlackBerry and the iPhone. The 2000s saw computing power and internet access continue to expand globally, with technologies like broadband, Wi-Fi, and 3G, 4G enabling constant connectivity. More powerful computers enabled great strides in science and medicine. Completed in 2003, the Human Genome Project used high-throughput sequencing to map the 3 billion base pairs in the human DNA sequence. This gave scientists immense insights into genetics, disease, and potential medical treatments. The project would not have been feasible without the computer processing power developed over the previous decades. Social media transformed online interaction, and communities with sites like Facebook and YouTube. Mobile computing went mainstream with smartphones and tablets like the iPad. Cloud computing also rose in prominence, providing internet-based data storage, software, and processing power. The 2010s through the present day have seen even more exponential advances building on these trends. AI and machine learning are now powering technologies like virtual assistants, recommendation engines, self-driving cars, and more. Quantum computing promises even greater performance gains, tapping into quantum physics. The Internet of Things, or IoT, connect appliances, vehicles, home energy, and much more, into data-sharing networks. Augmented and virtual reality tools immerse users in digital experiences. Looking to the future, computing will likely become even more integrated into every aspect of daily life. Ubiquitous computing power, connectivity, and AI seem poised to transform society in ways we can only begin to imagine, from personalized healthcare to autonomous transportation and beyond. But the basic vision of computation as a tool to aid human goals remains unchanged from its origins many decades ago. Finding massive reach into the entertainment industry, gaming has also emerged as a major application of computing. Arcade games like Pong in 1972 showed the possibilities for interactive entertainment. Home consoles like Atari, in the late 1970s and early 1980s, brought gaming into the living room. The video game industry has grown tremendously since its early days, now generating over $150 billion annually worldwide. Modern video games feature rich 3D graphics, online multiplayer worlds, and a level of immersion unimaginable just decades ago, all made possible by advancing computer power. Cryptocurrencies like Bitcoin, introduced in 2009, also demonstrate the scale of modern computing systems. The decentralized Bitcoin network relies on vast numbers of computers to maintain a public ledger of transactions through cryptographic proof of work. This requires enormous amounts of computing power, with the Bitcoin network now consuming over 200 terawatt-hours per year, more than many mid-sized countries. The energy usage has raised environmental concerns, but also shows how integral computer processing has become to running large-scale systems worldwide. In summary, the evolution of computers has been driven by major innovations in hardware, software, networking, interfaces, and much more. Starting from humble beginnings post-war, computers now underpin modern civilization. The exponential growth of computing power and connectivity will likely transform society even more profoundly in the decades to come. Thanks for watching.